Jen, today we are going to learn about Starstruck, that means the information encyclopedia about stars. First thing you need to know about stars, they are burning huge balls of gas that produce energy. As said, the universe is filled with energy as the stars generate a lot of them. So how does energy get into them? Well, in the core C there is very amount of fuel, hydrogen, helium, hydrogen, helium, and after that argon, neon, etc. It converts to that. So it's clear that they all fuse together. The two nuclei under high pressure and high temperature, they fuse together and become the next one, like hydrogen to helium, helium to neon, neon to argon, argon to krypton, and after a couple more elements it turns into iron. Now iron is fusion ash. It will just stay in there and form a huge ball of iron, and when the star implodes due to supernovae, it will blast out. And after, if there is a formation of gold, there is formation of that, but the gold is formed after the star dies twice. Now see, I will explain it later, but now let's just get a view of it. The star dies, supernovae, neutron star takes birth, and the neutron stars, if they are dual, that means the star is big enough to make a dual binary system of neutron stars, and then they perform a kilonova, then we can say the star died twice, and when it dies twice, gold, silver, the heavy elements are formed. So we can say for these stars, to make the precious gold we wear without care, they had to die twice. It took a lot of time. It cannot come back once it's used. So first let's learn about this a bit more. So in the core we learned the fusion takes place, and in the radiative zone the energy is released. It travels through the radiative zone. The radiative zone is very dense. After it gets transferred to the convective zone. Now the convective zone has tiny cells in it, and colliding those cells, the light particle takes a lot of time reaching the outer side, so that we can say the light we are facing right now has traveled through hundreds and millions of years, colliding through these cells and reaching to us. That just shows us how sophisticated the stars are. And after we find the photosphere. So the photosphere is like the glare of the star. It's like the atmosphere. Like Earth has an atmosphere, our star has an atmosphere too. Too hot for life. And okay, so it has an atmosphere, photosphere it is called, and as we can see, it's 6500 to 4000 Kelvin. That's a lot of temperature. Now getting back here, in this one we can now talk about flares. So flares happen when very big chunks of the star rise up and they form solar flares. So we can say that, and how this happens is due to magnetism. Magnetism after dynamo effect, the columns rising up and down in the star, they form a magnetic field, and in that magnetic field, once released like that, like we can say there is a magnetic field like semicircle happening. Now it will stretch out, वो oval बन जाएगा, वो ऐसे है, वो ओवल बन जाएगा, और ये हिस्सा टूट कर अलग हो जाएगा, वो इतना सा बढ़ जाएगा और इतना हिस्सा टूट कर बाहर चले जाएगा. वो मैग्नेटिक फील्ड थोड़ा सा फ्लेयर्स भी ले जाएगा. इसलिए जो मैग्नेटिक फील्ड होता है वो अर्थ का भी मैग्नेटिक फील्ड को, इस फ्लेयर्स उसको भी इंट्रैक्ट, उसको भी डिसरप्ट कर सकते हैं. इस साल 2025 कहा गया है कि जो सन का सोलर एक्टिविटी होगा वो हाईएस्ट होगा. तो लेट्स होप नो सोलर फ्लेयर हिट्स अस. And we can now talk about all the weird stuff that happens to star after death. We learned what happens in their birth. Now let's learn how they are born before death. So how they are born, like there will be a planetary nebula. Now neutron stars here, they exist, but they are not technically stars. They are the death of stars. They are obtained after death of stars. They are not technically stars, we can say. So after this is formed after a planetary nebula. It spirals, it gravity, and it forms into one star. There can be many planets around it, a mini version of itself, but too small and too cold for fusion. Okay. After that, we can now learn about the death of the star. The star can die two ways. Now there's this Chandrasekhar Seema that says after the star, our sun is right in the middle, 1 point something times it will result in a star so big that it will cause supernovae. Now stars that are kind of small and supernovae type, they can create neutron stars, and the stars which are big, they may create a very huge black hole, supermassive etc. black holes, and that's how they die. But if it's below the Chandrasekhar Seema, like our sun which is at the average, it will die too. Now they die, they form a red giant. It is said that the core of the sun will increase by 100 million degrees and it's turned into a red giant. So by red giant it will become so big that it will engulf Mercury and Venus into itself and probably burn up Earth by the heat. So after that very huge massacre, after 100 million years or so, the red giant will evaporate and it will leave behind a white dwarf. Now after that evaporation and the fading away and all, we come across a white dwarf. So the white dwarf will stay for many billions and quadrillions of years. After those times, the white dwarf will evaporate into a black dwarf, and after evaporating into a black dwarf, so sorry, we can say evaporating, I am saying because it's fading away. So we can say it's radiating away into a black dwarf. Now black dwarf is the last thing that will occur in the universe. After billions and trillions of years, after all black holes die, black dwarfs will still be there, and due to the immense pressure, like the electrons and positrons will fight, and there will be more mass and no charged particles to make it force out of that. Like normal thing, it has its charged particles, it has electrons. Now the opposite of it also has some it also has like electron, it also has positrons. So after a long time it will start fusing and it will be a big explosion. The last thing that will ever occur in the universe will be the death of a star twice.